Hey guys, we're going to do a video here to kind of get us going on how to graph inequalities. And specifically, I'm talking about two variable inequalities. So just to kind of review, since this is kind of our question today is like, how do I graph a two variable inequality? Let's kind of go back in time here for a moment to how do I graph a one variable inequality? Because that's going to help us out. Remember, one variable inequalities are things like this. Like I tell you, I have x is greater than 5. And if I want to graph that, typically we put it on a number line. If x is greater than 5, I'm going to set up my number line and I'm going to go to 5 and circle it. And because x is all the greater than values, I'm going to shade all the greater than values and draw this big arrow showing that x can be anything bigger than 5. It can be 6, 7, 8, 9, 10, and on and on and on up to bigger numbers. It keeps on going. What I'm not going to do is I'm not going to fill in a solid point at 5 because there's no equal sign. X is not equal to 5, it's only greater than 5. So I leave an empty hole and I shade it to the right. Okay, so that's a one variable inequality, a little bit of review right there. But I'm not talking about that today. I'm not talking about one variable inequalities. I'm talking about two variable inequalities. So let's look at a two variable problem. That should be our next step here. What's a two variable problem? Well, here is a two variable problem. Let's say you had y is less than or equal to 2x minus 5. Now I have an x and a y, two variables, hence the name. And our job is still the same. We want to graph it, but we can't graph it on a single number line anymore. Not when there's two variables. Instead, if I have a two variable problem, the way I'm going to graph this is on a two variable graph, an xy axis. So this is an xy axis coordinate graph problem. And I'm going to show you how to do that today. I'm going to kind of teach you how. So we're going to graph this thing using what we know about lines. I can tell by looking at this equation that this is a y equals mx plus b problem. It's just not equals, instead it's less than or equal to in this case. But I can see the m and the b. The m, the growth number, the slope is 2, and b is negative 5. So only going on that factor, I know some things I can do on the graph. I know, let's see, I'm going to grab some pens here that kind of help me write this out. I know that negative 5 is going to be my starting value. So I'm going to start down here at negative 5, put a point there. And I know that 2 is my slope, so I'm going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I can do this for a really long time, but I don't need to do it forever. Once I get a few points, I can line my ruler up and see my line. But here's the catch today. When I go to draw my line, definitely not going to use my marker or my pen. I'm going to grab a pencil from over here because I might need to do some erasing later. I'm not totally sure. So I'm going to be very faint and light about all of my work today. I'm going to connect my points, draw my line with my pencil. I hope it'll show up on the screen here so that you can see it. And it's light and it's done in pencil so that maybe if I need to, I can go back and do some erasing later. Now I'm not done with my graph. All I've done is the line part of it. I still have to address the biggest part of this whole entire problem, which is this less than or equal to symbol. Here's how we tackle this problem. We are going to test some points. We're actually going to run some tests. So I'm going to write tests. And what I'm going to do is I'm going to focus all of my attention on this line. I'm going to put my pencil on the line. There's the line. My tests are going to include both sides of the line. I'm going to test something on the left and something on the right. Or you can think of it as on top of the line and on bottom of the line. But I want to test something on either direction, on either side of the line. And I'm going to test something that's actually on the line. So I'm going to run 3 tests. Now something on the line could be any point on the line that I choose. So I'm going to choose this point right here, which is at 4 and 3. So I'm going to test 4, 3. And that is the point that is on the line. So I'm going to write on the line. But I'm also going to test a point up above and up down below. And you can test anything you want. So kind of reminding myself with my pencil that this is the line. I can test anything over here that I feel like. Doesn't matter. I could go to negative 2 and 3. I could go to negative 4 and 5. I could go to negative 5 and negative 3. You just have to pick a spot. I like to pick the easiest numbers possible. So what's the easiest number on this side of the graph that I could pick? Well, the easiest number is testing 0, 0. I mean, that's the simplest point. So I'm going to test 0, 0. And then I also have to test something that lands on the opposite side of this line, something over here. I don't have the luxury of doing 0, 0, so maybe instead I'll go out to 4, and how about 1, 2, 3? How about 4? We'll go to 4, negative 4. I'll test that point. Again, I'm circling it because I'm going to test it. It's just kind of a random point. So here is 4, negative 4. And now I'm going to organize this into kind of a table for my work. And the way I'm going to run my tests is I'm going to check them in the rule, in the equation. These are x values and y values. X values and y values. And so I'm going to take this equation. Y is less than or equal to 2x minus 5. I'm going to write it down. Y is less than or equal to 2x minus 5. And I'm going to test my point and see if it works. I'm going to put in 4 and 3 for the x and y. I'll put 4 here, and I'll put 3 here. And I'll see if that works. That means 3 is less than or equal to 2 times 4 minus 5. 2 times 4 is 8, and 8 minus 5. So 3 is less than 8 minus 5. 8 minus 5 is 3. So I get 3 is less than or equal to 3. And the question is that true? Is 3 less than or equal to 3? Well, yeah, 3 is equal to 3, and there's an equal sign. So this one passes. Pass. Awesome. Let's go test these points. Let's do 0, 0. So y is less than or equal to 2x minus 5. That means 0 is less than or equal to 2 times 0 minus 5. 2 times 0 is 0 minus 5. So 0 is less than or equal to 0 minus 5. So 0 is less than or equal to minus 5. Does that pass? Is that true? Is 0 less than negative 5? Now this one fails. That one fails my test. That is not true. So I'm going to go to my graph here, and I just tested 0, 0. And on my graph, here's 0, 0. And because it fails, I'm going to exit out so I don't forget. That is a failed point. Let's try 4, negative 4. Here's y is less than or equal to 2x minus 5. Let's put negative 4 for the y, and 2 times x, 2 times 4 minus 5. Let's test that out. 2 times 4 is 8, so I have 8 minus 5. So negative 4 is less than or equal to 8 minus 5, and 8 minus 5 is 3. So negative 4 is less than or equal to 3. Okay, is that true? Is negative 4 less than 3? Yeah, totally, pass. This one passes the test, that's true. So we have a pass, fails, pass. On the graph, that means that this point, 4, negative 4, which is right here, passes. And so I'm going to fill in the point so that I realize that that is a pass. The other thing that passed was the one that was on the line, 4, 3, which is way up here. Remember we had circled it? I'm going to fill it in now. Okay, so here's what that means. What does that mean? Well, that means that when I'm graphing my line, anywhere where the passes get shaded, the pass happened down here, I'm going to take my pencil and I'm going to shade on the passing side to show that the answer is actually all of this space to the right, all of this space below the line. And the line itself also passed. So because the line passed, I now feel confident in my pencil that I had drawn, and now I'm going to connect it with my marker, or darken it with my pencil, and show that it is a solid line because it passed the test. Now, if this point on the line had failed, I wouldn't have done that. I would have made the line dotted instead of solid, but it passed. So there's my final graph. I'm going to write y is less than or equal to 2x minus 5. And away we go. We've got a nice line. We've shaded the correct side. Only one side of the line can be shaded, either the top part or the bottom part. So I ran my test to figure that out. And I've drawn a nice solid line. Now let me show you an example that's different than this to kind of give you something to compare to. So now let's do one, maybe a different setup. I'm going to get some new paper here. Let's graph y is greater than x plus 1. Let's go for a nice simple line. Okay, so we're going to graph this on the xy axis. First off, as a line, it's a nice easy line. So I'm going to draw my xy axis, which you can do real quickly. this. I'm going to graph this mx plus b. I can see that m is equal to 1 and b is also equal to 1. So my graph starts at 1 here on the y-axis, and it's going up 1 over 1, up 1 over 1, up 1 over 1, looking something like that. So I'll put some scale numbers on here, just so I have a little more detail. And there we go. Doesn't have to be perfect, but a little more detail is kind of nice. And then I'm going to connect my points, but I'm not going to use my marker or a pen. I'm going to use my pencil, and I'm going to use it lightly so I can erase it if necessary. And I'm going to take those points and draw my ruler line, and I'm going to run my test. You have to run a total of 3 tests for these problems. One that's on the line, and then one above and one below. So I'm going to pick my 3 points on the line. I'm going to choose this one right here, which is at 3, 1, 2, 3, 4. It's at 3, 4. So I'm going to test 3, 4 for my on the line test. I'm also going to test something up above and something down below. Look at the easiest point that's down below. Remember, like using your pencil on the line here. Something down below that would be really easy is that 0, 0. I like 0, 0. It's a simple test for me, so I'm going to run 0, 0 as a test. Okay, and then I have to pick a third point to test, so I'm going to pick something that's up above here. Anything you feel like. So I'm going to go out to like -2 and how about here, 3. I'll just circle a point. So that's at -2, 3. All right, let's make a table. Let's organize our work. And let's label at the top that we are running some tests so that everybody kind of understands what I'm up to. And we're going to test all 3 of these in the rule that we were given. So the rule we were given was y is greater than x plus 1. So if I have to do 3, 4, 3 is the x and 4 is the y. That's 4 is greater than 3 plus 1. 3 plus 1 is 4. So you have to ask yourself, is it true? Is 4 greater than 4? No, 4 is equal to 4. It's not greater, so this one fails. The first test is a fail this time, which means 3, 4, which wasn't that on the line? 3, 4 up here, let's put an x in it. It is a failed point. Okay, that's going to be important. Now let's test 0, 0. Y is greater than x plus 1. I'll put 0 is greater than 0 plus 1, which is 1. So 0 is greater than 1. Is 0 greater than 1? No, 0 is not greater than 1. Another fails, which means there's another x at 0, 0. Let's test the last point, -2, 3. Y is greater than x plus 1. I'm going to put 3 here is greater than -2 plus 1. That means 3 is greater than -2 plus 1 is -1. Is 3 greater than a -1? Yes, 3 is greater than -1. So that's the first pass in this whole problem. And that means the only point that passes is this one up here. I'm going to fill it in dark. So what does that mean on my graph? Well, thinking of this as a line right here, the failed point was down below. Look, there's an X. The pass point was up above. So I'm going to be shading everything that's up above my line. All of this. And on top of that, let's think about the line itself. Did the line value pass? No, the line value failed. So when I connect it with my ruler, it's not a solid point. In fact, it's the opposite of that. It's a dotted line. I'm going to draw a dotted line to show my readers of my graph that the line failed. The line did not pass the test. So this is the graph of y is greater than x plus 1. So that was this is kind of a really fast video on how to graph inequalities, but big idea is this. You're testing 3 points to figure out if you shade above or below, and one of the points is to figure out the line. If it passes, it's a solid dark line, and if it fails, it's a dotted line. So just kind of keep in mind that it's very important that you always run your 3 tests. And just like when we learned how to graph regular lines, you want details. So put your scale numbers on there, make a nice XY axis, use your ruler, be neat and organized. Don't make sloppy graphs because they're hard to read. Okay, I hope that video helps, and we are going to work on this in class a lot more. and it'll get more complicated as we go on. All right, thanks guys. See you later.